Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing linear programming. This is part 2, so you should have watched part 1 before attempting this video. And this video is concerned with graphing and shading given equations. So we're given the equations and we are required to graph the line or at least shade the regions according to the inequalities. By shading the unwanted regions of the grid, find and label region R that satisfies the following four inequalities. Y is less than or equal to 2. So which line corresponds to that? Excuse me. Which line corresponds to y is less than or equal to 2? So of course, this line here is y equals 2. And we want to be less than 2. So we're going to shade above 2. We're going to shade everything that is greater than 2. This is all now unwanted regions. Excuse me. This is all undesirable. Now we have y greater than or equal to 1. So we don't want anything below the 1. This is y equals 1, of course, here. So anything below that is undesirable as well. Y is less than 2x minus 1. So where is the line that represents 2x minus 1? So here, this is a positive gradient. M is positive. So obviously, the line that corresponds to this, let's call it L3, for example, is the line that is rising. So this is the line L3 because it has a positive gradient. Or you can just pick random points and see whether they fit or not. So for example, to confirm that this is the correct line, I can take this point here. This is 1 and 1. If we put 1 and 1, they should be equal to each other. So if we put here 1 equals 2 times 1 minus 1, this is a true statement because 2 times 1 is 2, 2 minus 1 gives us 1. So it is true, they are equal to each other. Now let's name the fourth line L4. And of course, the only remaining line, excuse me, so we did not shade yet. I apologize for that. So for L3, we want y to be less than. So moving along L3, we want y to be less than. This is the correct region. So the wrong region is pointing up. So let's just cross everything that is up. Let's just cross all of this out. I'm going to erase these arrows just so as not to confuse you. Finally, for the fourth line, the only remaining line is the downsloping line, which is this line here. This is the only remaining line that we need to analyze. And here we have y is less than 5 minus x. So again, less than means that we want the region that is down. So we shade upwards. So, excuse me, I crossed out some shading by mistake. So we have shading here as well. We have shading all around here. And now we have shading all around here. So the only region that remains that has not been shaded is this region here. This is the only region that remains unshaded. You can call it R or whatever, and this will be the correct region. So it seems that our R is the same as that of the marking scheme. By shading unwanted regions of the grid above, find and label the region R that satisfies the following four inequalities. So x is greater than or equal to 0. Of course, this is a vertical line that cuts the x-axis at 0. So this is the y-axis. And we want it to be greater than. We want to be greater than 0. So we want to remove less than 0, which is to the left. So I'm going to shade all of this here. And then for the second equation, I have x plus y greater than or equal 7. I would rather just have the y on one side alone. So let's have y greater than or equal negative x plus 7. So this is a line that has a y-intercept of 7. And the line that follows that meets this requirement is this line here. And we want to be greater, so we don't want to be less than, so we don't want the below region. So let's just shade everything below this line. Now, for the third line, we have y is greater than or equal to x. So this here is a line that has 0 intercept because it's supposed to be plus c, and c here is 0. So this is obviously this line that is rising up through the origin. We want y to be greater than, so we don't want it to be less than. So we don't want the downwards region. So we're going to shade everything that is below this line. Let me just shade more efficiently here. All of this region here is shaded. It's incorrect, it's undesirable. Finally, we have x plus 2y less than or equal to 20. So I would again like to isolate the y. So I have x plus 2y less than or equal 20. I will take the x to the other side. So 2y less than or equal negative x plus 20. If we divide everything by 2, this is y less than or equal negative half x plus 10. So this is the line that cuts the y-axis at 10. This is the c. So this is this line here. And we want to be less than, so we don't want to move up. So anything above this line has to be crossed out as well. Let me do proper shading here. Anything above this line is out as well. So it seems that the only region that has not been shaded so far is the region that I'm currently coloring. So this region here. This is our region R. So the marking scheme doesn't specify the correct region, but seems that we did all right. By shading the unwanted regions of the grid, find and label the region R that satisfies the following four inequalities. So we have x is less than or equal to 3. So we don't want anything beyond 3. So we're going to shade right of the vertical line. So let's just shade this part here. And it should be greater than 2. So it should be also not less than 2. So let's shade to the left of 2. I'm doing it rather quickly here. I hope you're following. We're just shading to the left of x equals 2. Now I have y is less than or equal to x plus 1. So the line that has plus 1 here, this is the c. So it cuts the y-axis at 1. So we're talking about this line here that cuts the y-axis at 1. And we want to be less than this line. So we want to be below, so we don't want to be above. So let's shade above this line. Let me do this here. Let's shade above this line like this. And finally, y is greater than 4 minus x. So this is the line that cuts at 4, because the c here is at 4. So therefore, we want to be greater than this line, so we don't want to be below it. So let's shade below this line. The unwanted region is below this line here. So the region that has not been shaded in this question is this region here. This is region R, and this has not been shaded. So this is the correct region identified. By shading unwanted regions of the grid, draw and label the region R that satisfies the following inequalities. So we want to be between -2 and 3 for x. So we need to go to -2 and 3 and draw vertical lines. So our region lies between, excuse me, I made a mistake. So between -2 and +3, not -3. So the second line should be here. And we need to be between these two lines. So let's shade everything outside them. Now we want also to be less than or equal x plus 3. So to draw this line, first get the intercept. The intercept is 0, 3. And then put x as 1, for example, you will get 1, 4. If we put x as 1 here, y is equal to 4. So therefore, we join the line 0, 3 and 1, 4. This is our line here. And we want to be less than this line, so anything below it would be okay, anything above it would not be okay. So our region is this region here, R. And this is the correct region. By shading the unwanted regions, find and label R, the region R that satisfies the following inequalities. So here we want to be less than or equal to 5 for Y. So we need to draw Y equals 5. And we don't want to be more than 5. We want to be less than 5. So let's shade above 5 like this. Here we have 2x plus y greater than or equal to 6. So let's just rearrange this in slope-intercept form or gradient-intercept form. So y is greater than negative 2x plus 6. So the intercept here is 6. So we want the line that starts at 6 on the y-axis. So this is L2, for example, then this is L2. This is the same line that we're talking about. And we want y to be greater than, so we want to shade below so that above would work. We want to be greater than, so anything above is good, anything below is bad. So we want to shade the bad region in a sense. So let's shade everything below this line. Excuse me. Just try to figure this here. So anything below this line will be shaded. And finally, we have y greater than or equal x plus 1, which has not been graphed, so we need to graph it. So we're just graphing y equals x plus 1 in a sense. So you can draw a small table like this. When x is 0, you put 0 here, you get y equals 1. When x is 1, put 1 here, 1 plus 1 is 2, so y is 2. We have 0, 1, and 1, 2. These are the 2 points that constitute this line. So we have 0, 1, which is this point, and 1, 2, which is that point. And we want to join them together, so we get something looking like this. And for the inequality part, y is greater than or equal x plus 1. So we want the upper part, we don't want the lower part. So let's just shade below this line here. Let me erase this arrow so as not to mistake it for shading. And this is our region R. Excuse me. So for this problem here, the region R satisfies these inequalities. Draw and label the region R that satisfies these inequalities. So for the first line, we have y is less than or equal to x. Let's draw a small table here. Let's call them, for example, line 1, line 2, line 3. So here we're preparing for line 1. So for line 1, we have x and y. Let's put x as 0 and y and x as 1. So if x is 0 here, y is 0. If x is 1, y is 2. We have 0, 0, and we have 0.12. And we want to draw this line passing through 0, 0, and 1, 2. So this is 0, 0, and this is 1, 2. So the line looks something like this. It might not be very accurate. Let me draw it again. So it will pass through this point and this point here and this point here. So maybe this here would be a better line. I'm just drawing on the screen, so it's not a very easy procedure, but you get the idea. With the ruler, you can draw a much nicer shape. So y is less than 2x. So we want to be below, we don't want to be above. So let's just shade all the region above, because here y is less than, so it's below. For the L2, we need to first isolate the y. So we have 4y greater than or equal negative 3x plus 12. And then divide everything by 4. So you get y greater than or equal negative 3 over 4x plus 3. Now create a table to draw the line. So first, always start with 0. If you put 0, you get y equals 3. The second number should normally be 1, unless you have a fraction next to the x, in which case it's best to use the denominator of the fraction as the value of x, because then they would cancel out and you would have an easier number. -3 plus 3 is just 0. It's easier to calculate if you use the denominator as your value of x. So you have 0, 3 and 4, 0. These are your 2 points for the second line. So 0, 3 is this point here, 4, 0 is this point there, roughly, and you just draw a line that joins them together. In our case, we want y to be greater than, so we don't want anything below this line. So let's just shade everything below this line. Finally, we have x is less than or equal to 3. This is quite simple. You just draw a vertical line at 3. You want to be less than, so let's shade everything that is greater than. So all of this as well is out. Therefore, this is our region R. And this is the correct region. Again, we want to shade the unwanted regions to find the region R. So for the first one, we have a line that has a y-intercept of 6. So it's definitely the line passing through 0, 6, which is this point here. And we want y to be less than, so we want to shade above this line. So we're going to shade all the way above the line. It's best to just locate the line using the intercept. And then for the second line, the intercept is -4. So we're talking about this line here. And this time y is greater than or equal. So therefore, we want the region that is above. We don't want the region that is below. So let's shade everything below this line here. And then let's erase this arrow so that we don't mistake it. Finally, we have x plus y greater than or equal 5. I would like to isolate the y here. So y is greater than or equal -x plus 5. So the intercept here is 5, and we're talking about the line that cuts at 5 here, this line. And we want to be above it, not below it, because y is greater than. So since y is greater than, we're going to just shade everything below this line. So, excuse me, the only unshaded region here is this small triangle. This is our desired region. Find the largest value of x plus y in the region R. So the largest value would probably be at the top right corner of the region, which is this point here, because this is the largest value of x, or here, or here. It has to be in one of the three corners. So we have to figure out, using the coordinates of the three corners, what the maximum value is. So for the first one here, this point here has coordinates -2, 7. For the second corner here, this seems to have roughly coordinates 3 and around 4.5 maybe. So 3 and 4.5. And then for the third corner here, we seem to have 2 and 3 roughly. So we have to test these 3 points to figure out which one works best. So the first point is -2, 7. And the second point is 3, 4.5. And the third point is 2, 3. So the largest value here would be 5. Here would be 7.5. And here would be 5 again. So therefore, 7.5 is the largest value. So the triangle is correct. Their answer was 7. Maybe I made a mistake with the point of intersection. Maybe it should have been 3 and 4 rather than 3 and 4.5. This might have been just due to the accuracy of the drawing. However, let's check again. So it's slightly less than 3 and slightly more than 4. So it's this point here. And You want x and y to be integers, so that doesn't work. So you have to move slightly to the left. You have to take this point, for example, or this point. So actually this point would be 2, 5, and this would be where the largest value is, and the value would be 7, not 7.5. I misread because here they necessitated that x and y are integers, so we cannot just take any random point. We have to take the point closest to the corner where the x and y are integers. So this is 2, 5. This is the largest point. So moving on. By shading the unwanted regions of the grid, draw and label the region R, which satisfies these three inequalities. So let's start with y less than or equal to 2. This is a horizontal line cutting the y-axis at 2. And we want to be less than, so we don't want to be greater than, so let's just shade everything above it. Then x is less than 3. Remember, this is without an equality sign. It's not or equal. It's only less than without the or equal sign. So we have to draw a dashed line, not a solid line. So we have to draw a dashed line very carefully here. And we want to be less than this line. So we don't want to be greater. We don't want to be to the right of this line. So we would just shade beyond this line to the right, like this. Finally, we have y less than or equal x plus 4. So let's take 2 points on this line. Let's use a table, x, y. So either x is 0 or 1. In this case, y is 4. In this case, y is 5. So from 0, 4 to 1, 5, you draw a line and you extend it, of course. It will look something like this. And we want to be below this line. So let's shade everything above this line. So therefore, our final region is going to be this region here. And remember that part of it is dashed like this. And this is our final answer. We can label it R, of course. And this would be our final answer. So this seems to be correct. By drawing suitable lines and shading unwanted regions, find the region R. So we have x is greater than or equal to 2. So let's draw the vertical line here, cutting the x-axis at 2. Y is greater than or equal to x. So y equals x has a very nice and simple table, 0, 0, 1, 1, 2, 2, and so on and so forth. So you can just plot any points where x equal y, and you draw a line as such. So I forgot to shade the first line. Always shade before you draw the next line. So for the first line here, we are greater than 2. So let's shade everything less than 2. So less than 2 means to the left of 2 here. For the second line, we want y to be greater. So we want the part above the line. So let's shade below the line. And then for the third equation, let's first isolate the y. So we get y less than or equal negative 2x plus 8. Again, let's draw a small table here. xy, 0 and 8 and 1 and 6. Just plug x as 0 and 1 and find the value of y. So we have 0, 8, 1, 6. Let's draw these here. We have 0, 8 and 1, 6. This is our third line. So we can also just draw some more points to make life simple because I'm using my screen. So the line will pass through these points like this. And then it should be at the 4, should be cutting at the 4 here. And we want the y to be less than, so we're going to shade everything that is greater than. So let me draw this line again because it was not very accurate. So it should be something more like this. And we want y to be less than, so we're going to shade everything above it. So we're left with a very small and very particular region here, which is this green triangle right there. So for this triangle, we have 3 corner points. One of them is the intersection of x equals 2 and y equals x. So this is obviously going to be, this was supposed to be 2, 2. This was supposed to be here 2, 2. You can always do it by solving the equations simultaneously. Let me show you how to do that. So let's first label the lines very quickly, just to get the corner points. So this is L1, this is L2, and this is L3. So we're going to solve 3 pairs of equations. So for L1 and L2, where do they meet? We have x equals 2 and y equals x. So the only point that could manage these 2 equations is 2 for x and then 2 also for y. So this is the first corner point, which is where the first 2 lines intersect. This is L1 and this is L2, and they intersect at 2, 2, which is this point here. And then we have this point here is where L1 intersects L3. So for L1 and L3, we just have x equals 2 and 2x plus y equals 8. We have to plug 2 into this part here. So 2 times 2 is 4. 4 plus y equals 8. So y has to be 4. So our other coordinate here is 2, 4. Finally, for the third point, which is the intersection between y equals x and 2x plus y is less than or equal 8. So y equals x and 2x plus y equals 8. If we solve them simultaneously, we get 2x plus x equals 8. So x equals 8 over 3 and y equals 8 over 3, because obviously here 3x equals 8. And so we get x equals 8 over 3, and therefore y equals 8 over 3 as well. So our third point would be 8 over 3 and 8 over 3. So the sum here would be 16 over 3. The sum here is 4, and the sum here is 6. Obviously, 6 is 18 over 3, so this is the largest value. So the largest possible answer here would be 6. So you can either get it from the graph, but for my case, because I'm drawing on the screen, it's not very accurate. So I just solved simultaneously until I got my points. So 6 is the correct answer, and the shaded region is correct as well. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.